Okay, so I think we can start. So, hello everyone, and welcome to the Introduction to 3D Modeling workshop. My name is Maxim Surkov, and so I say some words about myself. So, you can call me a 3D modeling enthusiast. I have some experience in 3D Studio Max. I worked in it 8 years. And after that, I switched to Blender, and it was 1 year ago, and it was completely a game changer for me. So, and I'll explain why Blender for me works better. So, what's the motivation for actually learning 3D modeling? You may think that 3D modeling can be just for some studio artists. Well, no, you can use 3D modeling if you're not planning to do some game dev or rendering, because it's applicable in real life. So imagine you have some project like entrepreneurship course, and you need to develop a product. And so to make it more clear and represent visualize actual product, you can model it and show simple and where 3D modeling is used. Just some note here, I put some abbreviations. There are lots of abbreviations in the presentation. So CGI is computer-generated image, PBR is physically based rendering, and CAD is computer-aided design. And on the second part of the workshop, we'll have a practical part where we model a simple, really simple model of the bottle that I think you all know this one. So the fields of application for 3D modeling, starting from scientific modeling, going to CAD, the professional precision modeling, where it's important to have some measures, very precise modeling. Coming to visual effects in movies, here's a picture of the Gravity movie. Here you can see that actually 90% of the scene is CGI. Yes, and only the face of the main character is video footage. So it's nowadays it's really highly over. I think it's overused in the modern video industry, movie industry, and you can see here some artwork of Gleb Alexander. Gleb Alexander is a Blender artist. He works in a Blender, and he has a very amazing portfolio. So you can just Google him, and also actually I left some links in the end of the presentation where you can check some Blender tutorials, very nice Blender tutorials, and some links to really good artists. So here's the image you can see, it's complete CGI. So it's completely made in Blender, starting from modeling, texturing, rendering. So it's amazing, yes? And of course, the games. Games are made of 3D models. Without them, we couldn't make some games. Yes, we can make 2D games. They're awesome, but some studios and modern trends of games is actually 3D and very high quality visual effects. So let's start from explaining what actually 3D modeling is. So we're going to cover the polygonal 3D modeling, and the polygonal 3D modeling is about creating polygons. So what are the basic ideas? So example, we have imagine we have a space, and we put a point in space that has no weight, no dimension, just a point, and we call this point a vertex. This will be a starting point for our model. Or we can create several bunch of the points, bunch of the vertices, and connect them with edges. So it's like a graph. But when we have some loop of the edges, we can fill it with a polygon, creating a surface which is visible to the main viewer, to the camera. So we can render polygons. Yes, the polygon has no thickness, but it has two sides. So you can say that the polygon, yes, have two sides, and they are similar, but no, they are different. Actually, it depends on the rendering engine and representation, but we'll think that it's completely different two sides, because we have one side, we can build a normal vector from this side, that will be a visible side. But if you look from the other side, it's not rendered in free rendering engines, it's just invisible. So only one side of the polygon is visible. And this action of hiding the back polygon is called the backface color. And most 3D modeling software provide a very easy way of flipping this normals to make one side visible, other invisible, just by doing some, for example, on Blender, just one shortcut. You can press a key and normals will be flipped. So, and then you connect this polygon into an object. We'll call it a mesh. So the mesh is actual 3D model. So you can think, yeah, the modeling, 3D modeling is just about moving vertices in space and thus creating some shapes. Yes, it's that simple. But what is the art of 3D modeling? Why we need to study it? Why we have so much theory and so much things to do? It's just moving vertices. But the art of the modeling is actually how to do this as fast as possible, as effective as possible. So make it very quick, in a short time, create awesome models. The modeling software is supposed to help us to do this, to make it more easier, more simple. And what is the problem here? We have computers. We can render the 3D object there. You can see the example of some detailed car. We call detail. But imagine the computers like 10 years ago. They didn't have so much power as today's. And even today, computers are really big for visualizing some 3D, and all of the models, all the rendering is a very rough approximation of the real world. So we cannot simulate everything. That's like, imagine we have studied all the physical laws of the nature, but we can still not implement it in a computer because the computers are very big. And you can say that, well, we can render this car. Yes, we can render. But imagine it rendering at about resolution of the human eyes, 32,000 by 18,000 approximately. And that will be just, no, it's impossible. Not reasonable. So, so the engineers, programmers, mathematicians all the years ago developed some mathematical ideas to approximate these models and to make them more effective, to make the rendering more effective. So you can see here a basic, very basic model of a sphere, and it has polygons with 4 vertices. And what's the problem here? We can see all these polygons, but we want a very smooth sphere. How can we make it smooth? Just like say the first thing that comes to mind, increase the number of polygons, like million times more polygons. Then it will look much better, but the million polygons, they couldn't be rendered effectively in the computer and would be just very, not performance at all. So it's starting off a crunch build. So we build a crunch and we imitate good shading. So it's the same, has this model on the left has the same number of polygons as the model on the right, but it looks much better. And what's the idea here? We use a mathematical model that's called smooth shading. So it's a trick that allows us to spread the light so that it would look much smoother. But even with this trick, we have a problem. We have a very smooth shading, but we still have polygons. So if you look on the edges, there is a problem. There are polygons visible. Well, it's not a big problem if you will look in the modern games at the polygons of the models. You can see that these edges are there actually. Even if the model really looks good, but we cannot trick it. Actually, we have another approach to solving this problem, and I'll tell it about it later. So, here's another example. So, how do you think? How many polygons this object have? Approximately a few hundred. Yes, it's 128 polygons. And what about the model on the right? Same. What? Same. No, the model on the right has 11,000 polygons. And the model in the middle has the same number of polygons, but with a smooth shading. And you can really simply distinguish them by looking at the edges. So here's the smooth edges with lots of polygons. Here's the same model with 128 polygons. It has smooth shading, but the edges are the problem. And I included in the presentation some links to very interesting articles, so you can get the presentation and look at them. So let's stop talking about the modeling for now. Let's think about how the textures can be wrapped around the models. So yes, we have models, we have even materials, some shaders that we can apply to models, and actually these shaders are really good because they are scalable. They are based on the mathematical formulas, and they produce very good results that can be scaled to any resolution because it's produced actually while rendering them. But we also need to take some references from real life, like photos. We'll call these photos, the images, we'll call them bitmaps, because the bitmaps are the photos consisting of pixels, and they have resolution, the limited resolution. And we need to wrap that 2D, two-dimensional images around the 3D models. But how can we do such a trick? Because it's going stepping in one direction, up. So let's consider a very typical example of the cube. So I forgot to ask, how many of you have some experience in 3D modeling? Okay. It's very similar to making a model out of the paper. I think you all did this in maybe school, in the mathematics course. Yes? So it's very simple, just taking the cube, cutting the edges, and wrapping it onto the surface. So after this, we have a texture. So, yes, so make some cuts. It's a real cuts. We'll call them seams. So we make seams. And right until to unwrap the object and apply a texture to it. So, here is some task for you. So, don't think about the Blender shortcuts or everything. I'll show you on the second part everything. I'll just want you to think about these models. So here is the simple model. It's just 3 polygons in the space, like a pyramid. So how you can unwrap this model to lay it on the surface? Yes, the first thing that comes to mind is just take this object, select some edge, mark seam, and unwrap. So after this we have something like this. But do we really need to cut this object? Well, yes, it's a good approach, but we can just, stretch the polygons, because we can stretch the textures. And actually, it's used widely, the stretching of the polygons. So we'll just clear the seam, select it again, no seams at all. It's just 3 polygons. And wrap it again, and perfect. We have perfect perfect unwrap with just some stretching in the middle. But in the final result, it will not be really much of a deal. We cannot even see it. So another example, very similar, is just the half of a sphere. How you can unwrap it again? So it's very similar to the pyramid is just the sphere. So we can still cut this, make this cut here. Oh, no. And just unwrap it. Well, this is I think it's in my opinion a very strange thing. Yes, that they cut, and when we use some textures, for example, we don't really create textures for this model. We just take some textures like seamless texture. What is a seamless texture? So, seamless texture is a very simple thing. Yeah, just go here. So, the seamless texture is a texture. For example, let's imagine there are some things here. If we put textures, the same texture on the sides, and here, as a result, we'll have some surface made of these parts of this texture, the seamless texture. We can put as many as we want, and all of them will end up with the whole plain big texture. And it's also used widely. So again, if we apply the seamless texture here, we can scale it as much as we want, but it will be cut. So you can see the cut here. That's the problem. And again, a very simple solution is just not to do that. You just clear seam and wrap it. And here's a perfect circle. Some stretching here, but we can change the parameters of the unwrap very easily. You can just scale it, and the stretching is gone. Yes. So you want to, when you unwrap some objects, you really want to minimize amount of seams, because when you apply some textures, if you do not create the textures, anyway, that's a very bad approach to make too much seams. Actually, Blender, I guess, much other software allow us to do automatic unwrapping. It just makes seams by itself. But I don't trust this way because it creates so much useless cuts. So after the major unwrap, we can apply the texture, upload the texture, and for now we can see this texture is made of the color, and we'll call this a diffuse texture. So, and actually, every very complex objects are unwrapped the same way. So, again, about the complex objects cut. So, you can see here that on the face, we can only one cut. Only one cut. Everything else is without any seams. So, it's unwrapped perfectly. And we can lay this unwrapped on the texture and apply it. So the idea here is that every complex object is unwrapped the same way. So the process of unwrapping is usually done by the person who makes this model. It's called a modeler. And the creation of the textures for this unwrapped model is done by another person who is called texture artist. 3ds Max, Autodesk 3D Studio Max, Maya, and many other software do not allow us to create textures. They only allow us to make unwraps. But the Blender has fully featured texturing suite. I couldn't say it's the best in the performance, but you can do everything with it. So especially if you are creating some models for the 3D game, you won't really consider this very much problem with the Blender texture creation suite. And also there are specialized software like Subdivision, 3D Code, Pixel Suite. So it's separate piece of software which allows us to take the model and just paint the textures on it. So actually it's the most recommended way because these programs are specialized for this task, for text creation. And all of the professional 3D studios use separate programs for every task because they are more optimized. So back to our shading problem of the models. So we discussed previously that we can apply a little trick called smooth shading to the model to make the light more smooth without seeing the edges of polygons. But here's the next iteration of the smooth shading. It's called the normal mapping. So we've seen how to wrap the textures onto the model by unwrapping the model and applying textures. So how can we combine the smooth shading and the unwrapping to make it more controllable? So the idea here is to create a very similar texture, but it won't be used for the color. It will be used to simulate the details of the object, the details that are not actually exist in the geometry of the object. So do not confuse these with light maps. You know the light maps. So just light maps is just about writing the light into the textures. So you cannot really modify it. But with the normal mapping, we really write the information into the texture that will not be used as a color, but will be used as information about the shape of the object. So if you apply this to a plane, just a square plane with one polygon, and you will take some light source and move it around, you'll actually see that the details of the objects are really clearly seen, but there is no geometry. So here's the trick. Tricking the light. And so here's the process of doing such trick. So here's the original mesh, so the scope of 4 million triangles, 4 million polygons. And when you create a very simple simplified mesh of only 500 polygons, then you take the information about the small details and write into the mesh, and you get the mesh with absolutely the same amount of triangles, but the details are there. It's not the exact copy, because if you look closer, you can see that some details are actually missing, but it's very close. And also, why it is used actually? It's used to reduce performance, yes. We're doing all of this to make it render faster, to make it work smoothly. And after the normal mapping, we have another approach. So the idea of normal mapping was creating maps, so we can continue making maps that won't be used as a color, but will be used for information for simulating the physical properties of the object. So some terms, the plain color map, we see in the diffuse color map. This is just a color map. We'll call it albedo map. Many companies use different namings, but the scientific name is the albedo map. It's just a plain color. And in the true physically based rendering, it's not the same as a diffuse map, because the diffuse map is the color, and imagine like some photo. It's not just the plain color, it's affecting the light, some specular things, some sparks you can see in the map. But the albedo map reduces all the artifacts from the color and gives us only pure color of the object. So after that we have roughness map, the separate map for how the object will look reflexive, so it will reflect some other object will be glossy. It's all written in the roughness map, and how it's done. It's really very simple. We can have roughness from 0 to 1, where 0 is the no roughness, so it will be like a mirror-like surface, and 1 is complete rough object, will not have no reflections. And black is 0, and white is 1. And the gray is something in between 1 and 0, so it's just immediate roughness. So it will be just slightly glossy object on the gray colors. So we already seen the normal map. Here it is, of course. It simulates the detailed shapes. And something new, it's ambient occlusion. Probably you've seen in games some terms like SSAO, it's a screen space ambient occlusion. The screen space is just for rendering in the frame of the current view. And the ambient occlusion is this thing. It's just the shadows. So the blacks are, the color is a detailed shadow. So if you look at some object in real world, you can notice that on the edges there is some effect you can see the shadows in the corners. So it's just detailed shadow. So it's overlaid over the color texture, and you can see the ambient occlusion, the occlusion of the objects. Also, there is a metalness map, or some call it metallic map. So the metallic map is how metallic is the object. And unlike the roughness map, where you can have black, white, and the gray, some shades of the gray, on the metallic map, actually I don't have it here because the material is not metal. And on the metalness map, you can have only 0 or 1, because the object can be either non-metal or metal. So there's no grays there. And here's the combining of all these maps into the one object. You will get something like this. Do you think that this looks good? Mm-hmm. But did we forget something? Look at the edges. We didn't have anything to solve the problem with the edges. But why do they look good? We apply only these textures, only the shades, only the normal map that simulates the how lightning acts, the roughness map that shows us reflexiveness and the color. But why do we have that? Why do we have these nice edges? They look really good. And what? Transparency. No, we do not use transparency. Actually, this is a trick. It's called displacement mapping, and it's used in some games, but mostly it's used in highly performant rendering for studios, for movies. And what it does, it actually takes the map, again the white is, so the shades are how the polygon will be offset from the origin. So, and it uses, what's the problem with displacement map? We actually need geometry to do this trick, because it offsets the geometry. So, let's start. We have a plane object, plane model with a very low polygon count. It looks like this. Then we do tessellation. The tessellation is done automatically by the engine, and it's actually just taking these polygons and subdividing them a lot. So it will result a lot of polygons, and then we take these map, apply it to the object map. You can see the offset from the original object. But it requires geometry. You cannot do it without geometry. But the result is good. So, yes, the normal mapping, also called bump mapping, it's not purple here, but it's about the same. It doesn't affect geometry. It can be seen with the light, but the geometry is intact. We do not move anything. But with the displacement map, we really change the object. So here's a small example of the metal shader. So taken the base color when applying some, it's not texturing, it's about basic materials, shaders. So taking the base value, so result some looking good metal. And what's the difference between step 2 and step 3? Can anyone notice the difference?
More intense colors.
Hmm?
Maybe more intense colors.
Probably, but if you look on these reflections, you can see that these reflections are blurry. But on these objects, the reflections on the side, are more detailed, and this is called effect of Fresnel. Okay, let's finish the thing. We have applied some texture, adding the detail, and then some manipulation with the texture. But let's look closer what the Fresnel effect is. So it's effect from the real life. So have anyone heard about the Fresnel before? Okay, so the Fresnel effect is widely used, and so I cannot think it's used in the games, but probably in the PBR, true PBR shaders, it's mandatory. So what's the effect? When you have some transition between two types of surfaces, so when you have some transition between two surfaces with different density, for example, from air to glass. So imagine this is air, and this is glass. When you have some source of light, and this light creates some rays, for example, this source of light, so the rays will go through the light. Some angle of refraction actually, but and some reflection, some pure reflection. It's not very intense. So what is the Fresnel effect is? When we move this object more to the angle, so imagine the light source here. So when it goes really grazing incidence, it will not go into the glass. So let's forget about this source. When we have a really small angle of ray of light, almost all of this ray is reflected, and almost nothing goes into the surface. So it's called the Fresnel effect, and it's also used in the networking when you have fiber optics, where you have some cables. So you probably know that the internet uses not only the copper-made cables, but also uses fiber optics, which are actually glass, and the transmitting information just transmitting the light, so just putting the light through the glass cables. So, and then we have this kind of cable, and the light touches the surface in this cable. It's almost 100% reflected. That's why it's so good to use some transitions between surfaces. There are also some other kinds of additions to this. But the main effect is that the smaller the angle, the better the reflection. And then it's not the linear dependency, because when you go higher angle, it will increase the reflection much more. So, and yes, everything has Fresnel. It's a nice t-shirt here. And I put the links to the Fresnel equations and stuff you can read. Yeah. So what about the lighting? So rendering highly uses the imitation of lighting, but we cannot really simulate the lighting how it is in the real life, because real life it's like the photons, some waves, and it's really hard to imitate them. Even if we know how the light actually works, I think don't really know. But anyway, we cannot simulate it as it is, and so we need a very rough approximation. And it also depends on the project you use. So imagine for some still renders in Blender renderer, then as a result you can have only one picture. You can spend hours, days, months of rendering. It's using a path tracing technology that is about tracing some paths, imitating the light. But anyway, it's just a very rough approximation. But for the games, we cannot afford these hours. We need like 50, 60, 120 frames per second. And that's even more approximation. And here is the link to the very nice video. I recommend the channel. It's completely in Russian. So this is a real nice video that shows the modern technologies of light, how they work. It describes completely many of the technologies. So I recommend you this video also. And so the rendering is simply finalizing the project, making some images. And what's the notes of the rendering? It requires a lot of processing power, and it has to be really nice and quick in real time to get stable frame rate. And when we do rendering, what goals do we have? We need to have a really nice result. So the result is most important thing in all this stuff. And reduce the defects, some possible artifacts, make it as fast as possible. And if you don't have some server-like power computer, you can use some paid servers like render farms. Of processing power, actually, some companies, I guess, use these servers. And these render farms are not only for for professional artists, but the NVIDIA released some cloud gaming services that provide some video streaming. Then you play on your computer, but the actual processing of the game happens on the servers. Yes, I've tried this technology like some years ago from the other company. It's called OnLive. Now there is no OnLive. Yes, probably someone heard about it. OnLive, GeForce Now. Well, I can see that even these years ago it worked very good, and I think it's the future of gaming because it works really nice. The servers that process games, and we don't need to carry some large server computers just to render or play something. So the subdivision. Subdivision is about creating more geometry from existing geometry. So let's consider two types of subdivision. A very simple subdivision. We already seen the tessellation that created geometry. It's very simple, similar to tessellation. So the main point here is not really affecting how the object looks. It only creates polygons, only creates geometry, but not affecting. And we also have camouflage subdivision, which actually affects the lighting, or affects the geometry, and for you to understand how the subdivision of camouflage works, let's consider something like this. Two edges. We need to subdivide. Let's take something like this. First, let's take the middle points, for example, another middle points, and etc. etc. So taking these edges and point here is taking 3 points and creating, subdividing these 3 points. This is important because as a result of multiple subdivision, you have something like a radius like thing. So always look at 3 points. Like here we have 3 points, and it will be subdivided like a sphere here. Also have these 3 points, and etc., etc., etc. So what's the difference between Catmull-Clark subdivision and simple subdivision? It's simple. Catmull-Clark subdivision affects the geometry and changes it, and the object will look different. And the simple subdivision also affects the geometry, creating more polygons, but the object looks the same. Everything is intact, actually. The adaptive subdivision, it's a real nice technique in 3D graphics. It's based on the relative subdivision. Here we have a camera. I think it's kind of an experimental feature, at least in Blender. I don't think this feature is available now. Okay, so the idea of the adaptive subdivision is to subdivide the objects more that are closer to camera. So the farther the object on the camera, these areas are not even seen by the camera, so they are even less subdivided. But as a result, then on the final image, the density of polygons here and here is very similar. So we don't need some over subdividing this, because the farther the object is, you can see lower details. You cannot see much details in here, so we can subdivide it less. Level of details, it's more related to games. It's very similar to adaptive subdivision, but it affects the whole object. So these all models are created by monoline, the highly detailed building, lower, and maybe invisible, so you can see this. It's no need to render it at all. So here's another example, and the closer the object to the camera, more subdivided it is. But unlike the adaptive subdivision, it is adaptive. So it's done by rendering engine, and this is done by modeler. But I think there are some technologies that allow us to decimate the objects to make it less detailed automatically. But traditionally, it's done by modeler, using different levels of detailization. And as we touched the 3D sim building in games, so here are the main points how the modeling should be for the games. We need to minimize count of redundant polygons. If the player can see that polygon, we don't need it. Use of level of details, prefer maps, textures, normal maps instead of real polygons, because real polygons are geometry, and geometry is requires high performance, requires lots of power. And the maps actually take lots of space. So there is also a problem with the normal mapping and the PBR texturing, because it requires lots of space. Every map has some like 100 megabytes. There are 5 maps who have 500 megabytes, so that's not very surprising that modern games have so much, like 50 gigabytes, 100 gigabytes. Lots of space are taken by the maps. And also, what's important for the free game building for 3D games, you don't need to use the whole PBR spectrum for that, because you can only choose the 3 maps, like roughness map, color map, albedo map, and normal map. So normal, color, and roughness. You don't need. Imagine you have a mobile game. Do you really need to take all the PBR spectrum there? It will take lots of space, and it will actually look decent with only a few maps. And also, what is important is triangulation, because game engines usually always triangulate the objects So they use polygons no more than 3 vertices large. So only triangles. There can be polygons with 4 vertices, like more. They're called n-gons. But in games we use triangles. So some notes: the person who builds levels from pre-made models, just putting the models on the map, is called the level designer, and the person who plans how the level or some character will look is called a concept artist, just creating some painting, some artwork, how it will look like. It's called concept artist. So let's just stop about modeling here and think about the principle. Doesn't matter if the object looks good and doesn't require lots of performance. So will it be good? So how do you think?
One question is supposed that mostly major materials takes performance, not just a couple of minutes of polygons.
The amount of details the maps carry, the amount of details is much less, need less power. And also these materials are modular, so we can take, for example, if we created some PBR material, we can use it on any model. But what about modeling a street with lots of rocks and modeling each rock? And it can just be not very good. And if we want some speed, actually the speed modeling, we can just download these maps. It's more easy to find models. So the maps are better in this sense. So they're portable, and actually they carry more details than the really subdivided model will be.
Have 2 millions of polygons object on the map, and it will have no particular material at all. It won't be lagging, it's just polygons. It's
If
light
you-
and it's shadowing that improves performance, not just polygons.
Well, if you will take lots of, for example, one model of 4 million polygons and place it in some scene where are lots of such models, it will not be 4 million triangles. It will be much more, because you have several models, some maps, some models there, models here. That's lots of polygons.
I don't think that we should change from materials to high quality meshes. Yes, I thought that you probably shouldn't have PBR on everything you have, and different complex materials at all. Maybe on a weapon for shooters, yeah, sure. Maybe some bolts for RPGs and some, but not everything.
Okay, well, what's, for example, will not be completely no suitable for the PBR texture? Give me an example of some model that will be really bad when it's with a PBR texture.
Doing really bad.
Not suitable, like performance issue. I think. So you say that the polygons, amount of polygons, don't really exchange for the textures.
Trade-off between polygons count and material complexity. I mean, if you don't have a golden mean, you really gonna not shoot good performance.
Yes, okay. If you have really space-taking large textures, yes, you have a performance issue. But I think the textures takes space, but requires less performance.
Textures, yes, but their processing takes performance. Like you have, for example, holographic material, which is translucent, and you have multiple these objects roll one by one in a row, and you look just 3 FPS, and you don't it doesn't mean but doesn't you don't care about how many polygons you have. You'll be lagging because just it's material so costly.
Yes, materials actually take performance. They are not costless, but okay, we can discuss this later. So remember some old games like the Elder Scrolls Daggerfall? So do you remember somebody?
Yeah.
So this game at the beginning, so it has really simplified graphics. It was like not even 3D, it was simulation of 2D, like in early Doom, I guess. But what the trick they used? They put a real video in the beginning of the game, so they used real videos for the cutscenes. And actually it looked good. But do you think it's used in some modern games? Have you ever seen some real video footage inserted into a 3D game? Okay, probably. And also it takes about cutscenes. So some example from the Hellblade's Senua's Sacrifice. They used real actors, and they actually combined the real video footage with the 3D footage. So it's just blurred video. So the result is important, much important than the process of doing. Doesn't matter how you do, but do it fast, and the result is the point that we are doing. So we mentioned the normal map, but where do we get them? Actually, we can draw them. The texture artist can draw these purplish things. And one approach is actually to make this by painting, or using a substance painter, some software that will provide a very easy and joyful experience of doing these textures. But also we can do it in another way by doing the real high detailed model, then making or simplifying from this, or making high detailed model from this. Doesn't matter. We have two models. One is high detail, and one is approximate model with low details. And we can put the information, take the information from here, and write it into maps. So this is called baking. So we bake the geometry of the object into the texture. And then we apply take the same object, apply this texture to normal map to this object, we get nice result. So this is baking. And also wanted to show you another modeling technique. This is sculpting. Why it's different from traditional modeling? Because traditional modeling is taking like vertices and moving them around some techniques. But this sculpting is more like real world sculpting. It's very abstracted from modeling. It's actually for artists. So the geometry and everything, how it's shaped, it's all very simplified. So the artist could use it. The geometry this is called dynamic topology. Here the modeling, the sculpting is done using dynamic topology, and dynamic topology is ability of the software to create polygons by itself. So you don't need to matter to create even one more polygon here, one more polygon here, because you can take the brush and like sculpt or paint on the object. This is the artistic approach. And so going higher level of abstraction, we can have a really nice result. And this is done in most of the companies. So they don't model everything. They have sculpting workflow. And also you can sculpt very little details and then bake it into the low poly model. So that's how the characters in the games are created. And when we have these characters. So what's the problem with the sculpting? Sculpting usually is done with triangles because it's easier to make the dynamic topology with the triangles. And when you have a sculpt, there are lots of polygons. The geometry is really high, and sculpting the details requires lots of geometry. So to make the simplified model, we can use a technique called retopology. It's about laying low polygonal mesh onto the high polygonal mesh. So here are the links. So we come to the end of our theoretical part. Do you have any questions so far? So when you have this presentation, you can check out these links. They're really nice. And so we'll do the practical part, because when we do something, we understand it. So let's get into Blender. Everyone download the Blender?
Yeah.
Okay. As I showed you in the beginning, we are going to model a very simple thing. It's a bottle, and we'll import it into the Unreal Engine. So let's begin. When you open the Blender for the first time, you will see something like this. Probably you can have a different coloring scheme, but it's I'll show you how to change it, how to customize Blender for you. Well, the whole interface of the Blender is really flexible. Let's start from the left part. This is the toolbar. So in this toolbar we have some actions. We don't really need this for now. I can say you they are not really used in real. So we can just hide this toolbar by pressing T, as I wanted to screencast keys, so you can see every shortcut. The Blender workflow is different from other softwares. For example, 3ds Max. I remember 3ds Max as using the mouse and clicking some buttons. The buttons on the top, the same buttons on the right. Toolbars, this is even the same buttons, and its whole process just clicking the buttons. But in the Blender, we don't need buttons. We have shortkeys. There are lots of shortkeys, and you can do everything, even loading the file, saving the file, doing some modifiers. Everything is done with shortkeys, which allows us to work very fast. I'll just set up the shortkey so you can see it. So I put the shortcut thing on the left, so you can see everything that I do. You don't really need this. This is actually the plugin, which allows you to demonstrate what you do. You don't really need to install it because what happened? Let's begin. So let's finish overviewing the interface. On the right side, we have interface, some panel with actions, rendering, different various stuff. On the top, we have a scene layout, so we can see every object in the scene. like hide it, disable editing. How is the navigation in this view happens? So let's look at this main view. The main button in on the mouse for the selecting and editing object is the right mouse button. So you can select objects with the right mouse button. But then you will ask, what the left button mouse button do? It's used as a complementary button, but in this 3D view it's used for moving this thing. What is this thing? Some strange point. So what it does? Actually, it's called a 3D cursor, and this 3D cursor is just a very relative abstract pointer that we can use for doing some stuff. So at first, how to create new objects. And also I remember from the 3ds Max the whole process is just like hunting for these arrows. You can hunt for them, like search for this point, and you can press it from the middle point, and it's just we will not use these arrows. We will not hunt for them. We'll use much more efficient approach. So let's finish with the 3D cursor. The 3D cursor allows us at first to create some primitives. You can call the menu for creating primitives by pressing Shift and A, and then it opens this wonderful menu. Then we can create basic primitives. Let's go into Mesh. We have planes, cubes, cycles, UV spheres, something like that. And we can delete the objects by pressing X, and it will ask delete. You can press the mouse. Actually, it appears just on the mouse, so you can right after that click left mouse button and it will be deleted. That's very simple. So you can just select with the right mouse button and delete. We don't really want to delete, so we can just move the button, move the mouse cursor. How to move the objects? The moving is done also by the shortcut. Just pressing G, you'll use it a lot. So press G, and it's just a random selection in the plane of the camera. But we need to move this object onto some axis. So we have X-axis, Y-axis, and Z. We, for example, want to move it on the Z-axis. It's a vertical. So we can literally press what X we want. Z. I press the Z button, and then it locks to the Z. I press the X, it locks to the X-axis. And Y, the same thing. We can also insert real number in here. So let's press G, X. We have a free move with the mouse. We can press Shift to move it more precisely. So very convenient. By pressing Shift, we can move it. Also, we can insert some number like 1, 2, 3, -3. It is showed here. So the offset when we insert the number is showed on the left bottom of the screen. Can everyone see this? It's here. It's -3. So it's very convenient. So we can G, X, 1. So it shows 1. Press Enter. It's moved by 1 unit. Some abstract units. I think it's by default it's meters. So it can be when it's imported to other programs. So 1 unit, for example, in Unreal, it's the same meter. So we can move it. We can also rotate the object by pressing R. selecting the X. Again, we can insert like 90 degrees, 180, everything you want, 720, any kind of degree, and it will move it very precisely. Also the shift also works here for the precise mouse positioning. So we can navigate with the middle mouse button. We can scale, we can zoom in using the scroll wheel, but in my opinion it's not very convenient, because we can use the shortcut. We can press Ctrl and press middle mouse button again, and here is more precise positioning. We can pan the view by pressing the Shift and middle mouse button. Also, we can even rotate the whole view by pressing Ctrl, Shift, and the scroll wheel. Really fun thing. So let's start modeling our bottle. Do you have any problems with Blender? So let's delete this cube. Also about selection, you can select the object, and if you want to unselect everything, you can press A. And it is also widely used, because when we need to select some certain objects and lots of objects are selected, we can press A. It will unselect everything, and then you can select only one object that you want. You can select by multiple objects by Shift, duplicate objects by Shift D, X, and with the Shift we can select multiple objects. Also, I forgot to tell you about another way of moving objects. It's again pressing G and using the middle mouse button. When you press the middle mouse button, it will not lock into this one X. It will use the closest at the moment. Also, there are local axis and global axis. We moved the object, so it has changed its position, and this information is saved in the object. It's its own coordinate system, and then we have the local coordinate system and global. Global is just shown by the grid. Okay, let's start creating our bottle. When we need to create some object, we can have a reference image. We can download them from internet or something like that. And let's create the image for that. I remember that in 3ds Max they used some offsets on the background, but then it would be hard to delete them. You need to use the console. But here they use images. We put images into the real view. So let's press Shift. Also, we remember that the models are created on the 3D cursor. So we need to create our model in the center. And we can just try to click on the model, just to click here, and no success. We need to put the 3D cursor in the center. You can do this by pressing Shift S, and here is the menu for moving objects relative to 3D cursor and 3D cursor relative to world. So let's say cursor to center. Now it's perfectly centered in the object, in the middle. And that's really convenient. Then you have to move some objects. Let's create some, for example, some cylinder that will be the base for our bottle. Let's move it onto the z-axis to the top, because you can see that it's going underneath the starting coordinate point, so we need to move it a little bit higher. but we need to do it precisely. So we can also snap to the grid easily by pressing Ctrl while moving. So let's press G, Z. It now moves on the Z-axis, but let's snap it into the grid by pressing Ctrl. So it's perfectly snapped, and then we press the left mouse button and object is perfectly placed on the surface that's called floor. Let's create a reference image. So for now it's taking the space. We need to hide this cylinder just by pressing H. It will be hidden, and on the world view you can see that this icon of the eye is also not shown, so it's just hiding. So you can hide objects by pressing H and unhide all objects by pressing Alt H. Let's hide this object and then create reference image. So we press Shift A, and then we need to do some plane. We can use the plane, but it's a real 3D object, so we don't need this for the reference image. We can just use the empty. So here in the menu for empty object, we have image. There's some strange thing appeared in here, and now we can go to the right panel. So the right panel is used rendering for modifiers. We don't see here modifiers because it's empty and it has no modifiers, but on the meshes we'll see them. Let's select this icon of free axis and then select the reference image that we want.
Can you share?
Yeah.
Yeah.
I need to share this.
We don't have such things on other computers. Sorry.
So have you got this? Это для референса. Ну, чтобы по нему создавать. Но это будет в бэкграунде. Мы делаем как, чтобы она была во view видно. Мне нужно что-то немножко удобнее, чем какой-то бэкграунд целится. Okay, we can rotate this image just by pressing R, X and 90 degrees. Putting the 90. Now move, pressing G, X. Move it here. Just doesn't matter where it is because it will be in orthographic view. Also about positioning in the viewport. There is shortcuts in the numpad, right numpad area. You can press numpad 1, numpad 3, numpad 7 to lock into the views. So here's the front view, top view, right view, and by pressing Shift and pressing the Control and Shift and pressing these numpad keys, we can alter that. For example, this is left, right, and by pressing Control and again 3, it will be left. Really simple. So in the front view, we need to move. Okay, we have very rough reference to our bottle, and now we can unhide our cylinder let's select our reference image where it is. Okay. So here's the reference image. It's a little bit small. Let's scale it up by pressing S. So it's still not really big. To scale it even more. So something like this. Just approximate position. We don't really need precision because it's a photo. It's not very precise, like the model. So now, okay, we have this cylinder. Now we can start modeling this. At first, the point here is that we have bad polygons on the top and on the bottom. They are n-gons. It means that they are polygons with multiple sides, but we need low vertices count polygons. And I'll introduce you to the another mode of the viewport. So we are now into the in the object mode. So the object mode is just viewing objects and moving them, affecting them using modifiers. And we have the mode. The mode selector is right here on the bottom panel. There is a sculpt mode, different painting modes, and we need edit mode. So the edit mode is affecting the actual geometry. Now we can select very typical thing, selecting of vertices. Here also in the bottom menu, you can select vertices, select edges, and select polygons. So you can switch between these modes. So for example, if you take some vertex, we can move it with the G. If you want to fix it, you can press left mouse button. If you want to disable this moving, you can press the right mouse button and it will return to the place. So the first thing we need to get rid of is these two polygons. Let's delete these polygons by pressing X. And now we have some menu for deletion. We can delete vertices, edges, faces, and also dissolve them. Let's not consider everything in detail right now. So let's say I want to delete faces. It will delete the face that I selected. So, we can just select this selector between vertices, edges, and polygons. So vertices will select vertex, the edge will select edges, and the polygons will select actually polygons. You can see the dots here is representing the middle point of polygon. So we need to get rid of these polygons by pressing X. Now we can fix them. Actually, I want to show you why I deleted these objects, these two polygons. Let's just show it again. So why I deleted this? Then you apply some subdivision. These n-gons will turn into something like that. I think this is terrible. And that's so here we have to think about the modifiers. I use the shortcut, but you can select the object and use this icon in the right panel and select some modifiers. So when we select it, we can select any modifier like subdivision surface that I use. This shortcut for the subdivision surface without taking this menu is pressing Ctrl and pressing some number like 2 or 3. And it will automatically set the subdivision. So here's the number that affects the amount of subdivision. So even when we subdivide this object a lot, because of these 2 polygons, we have a problem. Doesn't look like a sphere. It looks like some strange thing. So that's why we want to get rid of angles. Angles are subdivided very badly. So we need to delete them. Now we can create, select the edges. We need to select the whole ring, the whole loop of these edges. We can do this by pressing Alt and pressing the edge. Alt and right mouse button on the edge will select the whole loop. Now we can extrude it, and also we can lock them into some X, like Z axis and Y, X, but we don't want this because we want to do something else. Just
create new slice.
Yes, I created it using E button, E. So it's called extruding. We can extrude polygons, can extrude edges. So let's see some simple example from this side. You can press E, press X for example, or Y. So you can remember this, that Y-axis is yellow or green, Z-axis is blue, and X is red. You can remember this. Now let's continue. Select the edge loop, then press extrude. We don't need to move it, so we press the right mouse button, but there are still 2 edge loops contained in here. It's in one place, and the top one that we use is selected right now. So let's press S and we will scale it. We extruded it and scaled it on the same X position. Let's do the same thing on the bottom. Extrude, scale, extrude, scale by pressing ES. Now we can press ES again, and we want to merge all this loop, all these vertices. You have the edges selected, but we want to merge them into one point, and we can do this simply by pressing Alt M. So Alt M will select the merge menu. We can we have some options at center. Also, what's really convenient, we can even merge 2 vertices, and when we select them, we can select at which vertex we merge. So at the first vertex, at last vertex that we selected, and etc. Okay, we don't need this right now. So we filled the bottom part of the bottle. And now let's create the geometry of the bottom right away. We need more geometry. Let's create, so it will be just a small inset into the center of the bottom. It will be slightly up. So let's create a new edge loop. So by pressing Ctrl and R, when you point your mouse on some face, polygon, you can press Ctrl R, and it will allow you to create like a cut, a new edge loop. So you can create by using the scroll wheel as many as you want, or type the number like 20, 30, and it will create the number of slides. You can fix them and move them. Okay, let's use this technique on the bottom. Let's create a loop and use it here. Control R.
Now we know what you select.
So I press the Control R, then I point at the faces that I'm viewing right now, and then I press the left mouse button. Then you can scale it, and after that you can select the final position by pressing the left mouse button again. Okay?
Nope.
What's wrong?
Hey, Control R. And okay.
That's the problem here. You нету, короче, здесь еще одного лупа. Удали вот эту точку, нажми на нее правую кнопку, vertex selection. X. Теперь выбираешь луп. Теперь scale, ну, E, S. S. Yes. Тебя немножко вниз.
Ну, да, это нормально.
Окей. Ну, просто если сразу нажимать подряд, то, ну как, после этого она будет управлять. Теперь можешь еще один создать, и тогда можно будет написать. То есть лупы можешь создавать между двумя лупами. То есть просто между точкой и лупом нельзя.
Понял, как делать поле.
Okay. Let's return. So let's have a slight look at what we are getting. Apply subdivision. And if you remember how bad the subdivision on the n-gons on the top and the bottom worked, it was a really disaster. But now we have a really nice thing. So we applied the subdivision surface modifier here. And then we have subdivision level on view and render. View number is going to affect how many there will be subdivisions in the viewport right now, and the render affects how many there will be in render. So now it doesn't affect render because we do not render, we are in the view now. Okay. So if you remember, we need as less geometry as we can in a model to import it in game, especially for very minor objects. We can hide the modifier by pressing this eye icon, so it will be disabled. Okay. Yes, and I can switch between the view of the whole object and the wireframe by pressing Z. And there is let's take a quick look into the rendering. It's a very quick way. We can just press Shift and Z, and it will switch to the rendering viewport immediately. Also, we have several rendering engines in the Blender, and you can install more. For example, I installed the Radeon Pro Renderer. I haven't really used it, but I think I saw it like good. There is old Blender render and the new Cycles render that was introduced not a long time ago. So it's gives much more realistic result. The Cycles render. Okay, so let's press Shift Z again to return to our view. And now, at this point, our object looks like some barrel. It's like a very strange thing. and we need to fix this. Let's finish with the bottom. Let's turn on off the subdivision surface modifier just for now, just so it won't be much of the deal. And here I created not needed loop, so I don't really need this loop. So I can delete this. But how can I delete the loop inside the object? If you press X and press edges, it will delete edges, and there won't be anything that connects these polygons. So it will create a hole, and we do not want this. That's really simple. We can dissolve the edges, how it's called. And here is the same thing in the deletion menu. So we can press X and select dissolve edges. And it will be dissolved, not affecting the polygons. Really simple. So now let's work on the geometry a little bit. We want to put this part and this part. Let's select that. Now press G, Z. Also, you have a really wonderful feature in Blender called. No, I don't remember what it's called. Okay, what's the feature? When you move some polygons or some objects, we are affecting only these polygons. And if you have some large object with lots of loops, you don't really want to move every one of them one by one. You want to move them at once. So you have the relative moving. Okay, you can enable it by pressing O. So then you press O. Here is the little button, the proportional editing. It's called, yeah. The proportional editing will be invoked by pressing O again. It will be disabled, as you can see. It will be enable, disable. And there's even the mode, which is used like linear, random. The random is really nice. Okay, I'll show you this after the smooth. Now again press G, and now we don't move only the single object, only single selection. We move also the neighbors of these polygons. And by using the scroll wheel, we can select the area that it affects. So by doing this, we can create something very amazing. And also, if you want to make something random, you can use a random selector, and it's going to do something like really random stuff. Okay, what? Proportional editing. В общем, мы выбираем то, что у нас есть selection. Мы можем включить режим proportional editing, нажимая O. То есть можем включить его, O, ну или выключить. Также он отображается здесь. The shortcut is O, and the panel is on the bottom. So we can just enable it. For example, I don't really need to select anything. I just, for example, I want to move these vertex on the side and create some proportional editing. Press O, then, as always, press G to move, and now it will move this thing. And by using the scroll wheel, you can limit the area that it affects. So something like this. So the scroll wheel affects the area. That's like the smooth one. It was the random. So on the bottom you can select the mode, like smooth mode. Let's try spherical mode. We'll select as a sphere. Smooth mode, we'll just select smooth. We'll mostly use the smooth mode here. Sharp mode, very useful thing. So let's get back to our bottom part. Okay. Now let's select these edges again, then get to the vertices, select the middle point, move it into the top here. So now we have something like a bottom of bottle. It's too much. Press Z to view the wireframe. Okay, nice. So now we want to create these edges. Here you can see on the bottle there are some outsets. We want to create this, and again it can be done easily by using the technique that we already know, by cutting edges with Ctrl R. So let's move these two things on the top. More assembling the shape. So something like this. Now we can create these edges. How many? Let's think for a bit. How many loops do we need? We have 1, 2, 3, and 4. So we need to create 4 loops for a single this thing, and 4 for this, and 4 for this. Let's start. Press Ctrl R. You can move on the surface you would like to divide, and it will automatically snap this purple line. It will show you what it's going to subdivide, you want to cut. So let's create 2 by using the scroll wheel. Press 2. Now we can scale this thing by pressing again S, Z, and V. Let's move it on top. Actually, don't forget about the proportional editing, because sometimes it can be not really obvious when it's turned on, and now I forgot about that. And if you try to do this, it will also affect the edge I don't even select, because that's why we want to turn it off. Now let's position it. Something like that. Now subdivide this edge, and when I create these cuts here, so after I press it, I have to move the mouse button to select the position. But I don't want to select the position. I want for it to stay in the middle of these two lines. So I can press the right mouse button and it will return to the center. Now let's scale it. And scale it up a bit by pressing S.
Can you repeat this?
So have you this point? This point? We can cut the faces, create new edge loops by pressing Ctrl R. Then we can use the scroll wheel to increase the amount of them. We need right now we need 2. Then you press left mouse button. You can move it. We'll just press the right mouse button to reset it to the standard position in the center. Now we can scale it. We'll scale it by pressing S, Z, because I want to scale it only in Z direction. Now we can move them by pressing G, Z again. And now they are moved. You can just scale it up a bit more. Okay. Have you got this? Let's go.
Тебя в чем в прошлом видите по разобравочному величеству? Нет, мы скейлить их не будем сейчас. Сейчас будем создать еще один. Ты их пока заскейли по Z. Z. Теперь заскейли. Да. Тебя немножко не видно заднюю эту, потому что ее заскейлить тоже. Но для этого нужно выйти из edit мода, потому что сейчас ты несешь эту. Да, также ты можешь сделать с помощью таба. Скилли.
So we have the base for the. Now we can create more edges inside this. Also scale them up. And now we can scale this thing up. You can even scale them down. So we want something like this. Okay, let's quickly create the same things here. So we're doing the same manipulations for the top one. Okay, one more. You can create one by one. Also, we talked about how to scale in Z, X, Y positions, but what if we want to scale object or move object into two axes simultaneously? For example, I want to scale this thing into the X and Y axis, not the Z. So we can do this by pressing S, and now we want to exclude the X we don't want to use, for example the Z. So if we press the X, Shift and press the X we want to exclude, so Shift Z, it will be scaled into two axes simultaneously. In this example, it's not really obvious because if we scale them by pressing just S, it also works. But sometimes, if you want to move or scale object only in two axes, for example, if I want to make this bottle bigger in the, okay, I'll show you. So we can switch between the edit mode and object mode that we've seen previously by pressing tab. So it's quickly, it's the same as doing the object mode, edit mode. So we want to leave the edit mode, go to the object mode. So we're starting to see the bottle, but we see the edges between the polygons. We want to apply the smooth shading that we seen as the first thing for smoothing the light. We can call the toolbar on the left by pressing the T and select the shading. There's the shading, there's flat shading, it's right now, or the smooth shading. Now we can see what the smooth shading is about. There's no edges told. Okay, let's keep it like that. So then we select the edit mode even go. Okay, at this moment we have a very low detail, so the smooth shading looks really strange. Let's turn it to the flat again. We'll apply it a little bit later. So about the excluding, if you want to scale on the X and Z only, but we have S and it scales it uniformly, but you want to exclude Y, so press S, Shift and Y, and now it only scales in 2 axes, on the X and Z. So Y dimension stays the same. It's just a trick for you to know. Let's return it to this point. Now we're going to work on the details more. Let's turn on the subdivision, and you can see this it's looking something too smooth. Yes, so let's go to the edit mode again so we can see what is the problem. So do you remember that I said about how this Catmull-Clark subdivision works? It takes 3 points and creates on the radius of these 3 points the subdivision. So it's like a circle. So we have here the 3 points and it's subdivided. So to reduce the radius, we can just add 1 more point here. Let's press Ctrl R, and you can see that the radius of the subdivision decreased. So now we have more sharp edge, but still it's quite subdivided. Let's do this the same. Okay, that's scales. This can be a little bit more. Scale this down. Let's create some sharp transition here. Just for convenient use, I can disable the modifier right now, so I can scale it, insert 1 more edge, and now it will look more sharp. So when we move this, so also really convenient way of moving some edges or vertices that are already in the object. So at this point, we don't really want to move the edge loop. We want to make it closer on the same line. So on the line here, from here to here, we want to move it on this direction. So we can press G and press G another time, and now it will be like sliding on the polygons. That's really convenient. So we can slide it here. Now see what it does. So it created a little bit of sharp edge. So you can see here it's a little bit sharp. So to make it even more sharp, we can add this from this side. Okay, so I think we can leave the button like this right now. Just and scale it a little bit down here. Now it looks kind of good. Now let's work on these things. Also, what we want to do, we want to create even more edges to reduce the radius. So as you can see here, when we add these things, add new loops, we are reducing the radius to making it sharper. And the same thing with this part and this part. So it looks much better. Let's work on this part a bit. This. Now we can do this same thing. Here. Now starting to look, starting to take shape. Starting to look like a bubble. Can use the subdivision count. Let's do this same thing here. Even we can a little bit scale it up here. Proportional thing. So at this point we can have something like that. Let's scale it a little bit. Yes, it's starting to resemble the shape. Now let's go and do the same things on the top. Pressing E and pressing Z to fix it on the Z axis. Let's disable the subdivision for it now. So you want to look at the edges, and the edges will be the key points for this model. So let's press E, Z, scale it down. E, Z, scale it down. Press E, Z again. So let's keep this open and just create some like inset into the bottle to make imitation of the surface inside. If you would be doing this model for example for real rendering, we want to export this actual model into the Unreal Engine, so we need to make it with respect to Unreal. So we don't need to work on the part inside here. So we can, the one way to do this, we can simply work, for example, like that. We can create the surface inside. Now we can create even more surface and more inside the bottle around the inner edges, creating a realistic model of the bottle so it could have inside part. And when we applied some realistic shader like glass shader, principal shader, then we'll refract the light and look like real glass or plastic with refractions. And this will take a long time to render because shaders like glass and transmission with refraction takes a lot of performance, much more than just reflection. But we want to make this for Unreal Engine. So we will not work on the inner part. So for this reason, we can just keep it inside. Let's one more time. E, S, and merge them into the one point. So here we have whole bottle. And you can subdivide it, but we worked on these parts. Let's now work on this part, because it's subdivided too much. We want to create edges. Let's add more ones here, here, like this. So now you can see that I've scaled, and then I press Shift and the mouse button. The viewport really very like too slow. Like what's happening? I cannot move. It can probably happen to you anytime when you scale too much. And it's setting in the offset from the camera. You can reset this setting by pressing the dot on the numpad. So you can use dot, and it's scaled to the selected point. Now we can use it, and it's perfectly moving like we want. So pressing dot will reset. It's called the numpad period here, but it's dot on the numpad. Okay, so when you have viewport, then it's like a smoothie, something like that. You can press dot, and it will reset the offset, so you can navigate in the viewport again. Very good. Let's create some ones here. Check it how it looks. Maybe one more here. Something like this. Also, the software is not perfect. I'm talking about every software, so it can crash. So I would recommend you to save your progress as frequent as possible. So you can just press Ctrl S. Right now, this is saved into the temporary Blender files. But if you don't want to lose any progress, you can press Ctrl S, select the location, and press Save Blender file. And again, when we press Ctrl S, it will just ask to save over. Or we can select new location for it, save as, select the location, so here's the path to the file, it's a folder, and just select the name, or here we can bother and save. So save as frequently as possible. Okay, let's look again at our bottle. Now it's starting to look kind of good. We have lots of polygons. Let's reduce the amount of them. And at this point, we don't need the reference really. So we can either hide the reference by pressing H. And but for example, if we have some complex, very complex scene, we want to work on a single object in the scene. So imagine this like a scene of some city. We have buildings, lots of objects, and we just want to work on the bottle, so it won't affect that. And to simulate this situation, I want to create a floor and some walls. So let's just hide this for a minute. Now let's again press Shift S, cursor to center, because we had this cursor here. Create mesh plane, so it will act as a floor. Now you can create some walls, some duplicated, move it, something like that. Okay, I don't want to really go into complex walls, so just let's make it okay. So we have to work on this bottle from the bottom, but this floor is in the way. We cannot see the bottle. And imagine if there are lots of these objects. We can just go into the local view by pressing the slash button on the numpad, and it will be separated into the separate local view. So we can go to the local view of this wall or the bottle. So it's really convenient. Now let's look at this edge looks. Okay, so I think for now it looks kinda good. Now we want to export. We're starting to think about exporting the model. So at this point we can say it's like this one. Let's apply the smooth shading right now. Press T, smooth, select the smooth shading, and now it will look shaded smooth. Let's try to render it by pressing Shift Z.
If I press minus not on the numpad,
Well, I guess it's not used. Or like it's a delete thing.
no, it's an entry.
Oh, minus plus is just
No, minus not on the numpad, just on the keyboard.
well, I haven't really used it. So what happened?
Just disappeared.
Well, that's strange. I pressed the minus. You can you Control Z to that point? Did you save it?
Okay.
Okay. So let's render it really quick in here. Let's say we have scene again. We have a light source. Looks like this. Let's move it a little bit. So it's in default scene when I create in Blender file, we have some free objects that are by default. Cube that we deleted in the start, the light source, basic light source, and the camera. We will not use camera today, so we can delete it. It's used in the rendering of the Blender, but now we can also render that in the viewport. So talking about light source, let's get into materials. So in the cycles render, so as default you will be in a Blender render, and you don't really want to use because it's like old. It's much faster, but it's old, really outdated. So you want to use the cycles render. It's more realistic. And in the cycles, we have different kind of materials than in the Blender render. So materials created in the Blender render are different from the cycles one. So let's go into the settings here. Also, we have we have some toolbars in the interface. Let's talk about interface again. We have T, N. There's lots of some settings. Very funny thing is the shading. So it's in the N menu, backface culling. So as you have already you probably noticed. Scale it dot. So I told you that faces are invisible from the other side. But why can we see it from here? We're inside a bottle, but we can see the insides. That's why the Blender's rendering, like visualization in the viewport, has disabled the backface coloring, but we can enable it again. So if we enable it, they are invisible. Visible only from the outside. Also, there is some fun settings like the net cap. We can put the whole scene. It's just a viewport. It will not be visible in the render. It's just for your convenience to work in the Blender. So in here we can select some things like just like shaded materials. So, okay, gold. This is just for your convenience, like a ZBrush style. ZBrush is a program specialized for sculpting, actually. It has some clay color by default. Other styles, very different stuff. Okay, now it's just a matte cap, so we can going to turn it off. We can simulate the ambient occlusion here. So what's the difference with or without ambient occlusion? Here it is, the detailed shadows. Okay, but we want to turn this on, off again. Okay, and talking about the Blender's flexibility of interface. Each window in here is actually a multi-purpose window. So we can make this selector, this scene view window into anything. For example, I want another 3D view. So here we created another 3D view. And that's like anything. So you have these small triangles in the top corner and in the bottom corner that you can just drag, and it will create new window. So you can create as many windows as you want, so as much as you wish. Yes, and it's really convenient because you can select here, you can select like top view, select some view here. Let's just close them using the same thing, just dragging into here. Okay, so we can we can just scale up. Let's turn this again into the outliner and create. We have created this wonderful new window. And let's select this in the bottom corner. There's selector of the type of the window. So we can create any type of the window, like Python console. You can script in Python, like do some scripting for animation or stuff like that, generation. So you can create actually plugins for the Blender using Python. There's an API for that. And now we want to use the UV image editor. So UV image editor is editor for the images. So you can actually use the Blender like a Photoshop or like After Effects if you wish, because the Blender also has video editing software built in. So now we are going, so you work with the textures in this UV image editor. And I told you that to use some textures or materials, conceptuals, we really want to unwrap the model, because now the Blender and the software doesn't know what the hell is happening with the surfaces, because it has some polygons, But how can I put the texture on it? We need to unwrap it. And so how do I see this model? I can see this as a plane here. Now you have a barrel, like a cylinder base, and again one more plane here. So we have 1, 2, 3, 4 parts. Actually, we can also unwrap this one. So how can we cut the object so it can be put on the surface? Let's do some unwrapping. Let's scale down a bit. Let's select the edge loop here. I want to select it here. For now, we're going to disable the subdivision surface modifier. And now we want to create edge seam. We can create it by pressing Ctrl E, and then mark seam. You can also clear it. So we want to clear it. Press it, clear seam. So Ctrl E, mark seam. And we mark this, so when the blender will be unwrapping, it will cut on this line. So now we are going to cut, make another cut. For example, here we mark seam. Now we want to try to unwrap it. It's going to be, let's try, just try. So let's go into UV image editor and try to unwrap. So to unwrap, we can select all the polygons, press U. So to select all the polygons, you can press A. Now we can press U, and it will show us the selection tool. So we have here some things, but we need only unwrap, and also we can consider Smart UV project. I want to try. I'll show you the Smart UV project. It's the automatic tool for cutting the edge. So you can, if you use Smart UV project, you don't really need to mark seams because the Blender will automatically try to unwrap the model by itself. But we are unwrapping by hand, so we can unwrap it, and we can see very strange things happening there. Blender doesn't know how to. We have the cylinder, and we cannot cut it. So let's make another cut. And so I want to cut the whole edge, but if I choose to select it with Alt, it will select everything on that line. But we want only from this point to this point down here. So we can use the Blender's searching. It can lead the shortest path from one edge to another. So by selecting some edge, we can hold the Ctrl key and select another edge. It will find the way from that edge to another edge. So just searching the shortest path. And this can be used with that thing. So let's select this edge and follow up the way up. Let's go and cut this to this. And we have selected this cut nicely. So let's mark it, mark seam again. Now we can try another time unwrap it. We unwrapped the sides of the bottle nicely, so it's like very good looking. And now we have these circles. These circles are really bad because they are, for example, this surface, this to view which vertices are on the unwrap and on the model. You can use this icon here. So it will show us what edges we are viewing right now. So as we can see, this part is really pressed down. Let's make the unwrap let's make the drop next. So select this part, call E Maxim, select this part, make another scene. Also we can select this part. It will create separate unwraps. So let's try it. So now it looks better, and I've created several circles. And we don't really want to cut this circle from this point to this point because it's very good unwrap of it here, so you can perfectly see all the textures in it. So next, let's cut this point. Select this on the side, to the cut, Maxim, also this point. So I'm using the control to select the paths that I want. And now it looks kind of good. So let's leave it like that. What about this point? Okay, we can. Okay, so now we have some unwrap. We can even modify it by selecting. So if you have some part of the object selected by the polygons on in the same object, in the same mesh, we can select the whole object. So we want to select the part that is selected inside this cut. So we made some cuts here and cuts here. We want to select this whole unwrap by pressing L. Sometimes that work. Looks strange. Okay. Seems like it's selecting the whole object. Okay. So using L, we can select the whole object. Right, and okay, you can just leave it like that. It was just optional thing. So let's look again at our unwrap. Right. So now let's check how the unwrap actually will work. Here in the UV image editor, we can create images, open up images. Let's apply some texture. Let's at first generate the texture. Like so we are in UV editor, pressing the new, creating the new texture. Let's take the generated type to UV grid, and now it will generate this nice texture. Plus UV grid. Okay.
Wait, how did you open the right window?
It's so in UV image editor we have new button. Yes? No?
Wait.
So everyone found it? Any problems? So let's call it test. We'll just see it in title. So we need it just for testing. Now we can, in the viewport of the object, we can render it, but we don't see this texture. It's because we didn't apply it to the object. So let's go to the material creation suite. Let's change this viewport of the UV image editor to node editor. Now, in the bottom, we can select the icon of the material, and here will appear the material for the object. But at first, we need to create it. Let's go to the right, go to this sphere icon, and create a new material. And you have some simple nodes. So, have you found it? Let's go. From the UV image editor or something in this window, we can select the node editor, and it may be some set to like other types of view. We need this sphere icon here, select it to go, and before these these nodes appear, we need to create the material for the object. So with the object selected, so select object, it was already selected if you didn't unselect it. So if this is a selected object, you can go into this menu on the right, like a sphere icon. Have you found it?
Yes.
Okay, now there will be no texture, so you can create new material, and you will see this in the node editor, right? Don't you see that? So let's speed up a bit. So we can use this texture just for testing reasons. So let's create a node for our texture here we created. Let's, in the node editor, let's select create new node by Shift A. Let's search for image texture. So Shift A, search image texture.
Just image. So just check texture.
Image texture.
We don't have image texture, we have texture.
Yeah.
Well, what's wrong?
Okay, so we can connect this image texture to the default shader. Now we can open the file if you have some bitmap or something like that for the object, but we already created it in the UV editor, so we can select it right here. And now if we go into the viewport and render it with Shift Z, we will get that the model is textured with the sample texture we created. Or also we can show the texture inside using the view. So here's the button selector on the bottom that looks like white circle. You can select the texture view. It will also appear in just the viewport. So, okay. So if you look on this object, you can see that it's pretty much very good. It has good density of the texture because all the squares here are equally spread along the model. So that means we have the texture density equal on the whole object. So if you don't, so because we created the unwrap by hand, we really thought about how to create the unwraps, and because of this, we get this nice texture, this nice spraying of the texture. But if you don't, probably if you followed me, you have this one. But if any other future projects you have some problem, you can go into UV image editor and edit the UVs. So like for example, let's select this one. So by doing this, we can really scale anything. So if you have some density problem like this, you can just adjust it. So by default, in this bottle don't have this problem, so we'll just use this model. Now we want to export this model into Unreal Engine, and let's do this. Let's close this, go out of the edit mode by pressing tab. Now we're just in the simple object mode. Let's render it out a bit. Also, let's do some magic trick. A quick, I'll show you how the object could look if we use different nodes. For example, if I create different shader, BSDF stands for bidirectional scattering the distribution function, I guess. Okay, let's, for example, use some glass shader. Just for example, you can render it. So if you render it, we have some glass bottle. But we don't want to use this shader now. Just really looks like glass. We don't simulate real glass in game engines because it's too complicated to imitate the refractions inside the glass. So it was just, for example, in the rendering, serious renderings like Blender or some other stuff, not real-time rendering, we can have these nice shaders. And now let's export the model. So go out of the edit mode, and now we want to apply all the locations because definitely we moved the object, and the system that I told you previously, the local coordinate system, also moved. You want to fix that by pressing Ctrl A and apply the rotation and scale. It will just fix the coordinate system problem in the future and in the exporting process. So now we want to export it. So just press File, Export. We want FBX. Now we let's go to the desktop. Here's the important point. Now at this point, Blender wants to So we want to, so here's the FBX menu. If we'll export right now, we will export the whole scene as FBX, but we only want the bottle that we selected. So we press selected objects, and we can just right now export it by using the export FBX button. And it will be exported. So we have smooth shading enabled, everything is good. Now let's close up Blender a bit for a bit. Go into Unreal. So here's the basic scene. I guess it's a very default scene in the Unreal Engine. Let's just import the FBX model that we created. Import it. So it comes with some material, but we will create material for the game, for this project inside the Unreal Engine. So let's look at how the bottle looks like in the Unreal editor. So it's kind of look good. So we can view, we can disable material here, just default material. So with the UVs we can view them, with the UVs that we created. Later on is texture, maybe some information, normals, tangents, just the Unreal Engine stuff. So now let's create a basic material. We'll use a glass material for this. Let's apply it again. You can also create new material, but we'll use just the material that comes with already created by Unreal for this object. Let's rename it like some plastic. Now let's open that material. And so let's do some Unreal stuff. So what the point is, then I go to Unreal, I also noticed that I cannot, that the interface is really flexible in Unreal compared to other projects, but the Blender's is way more flexible. Also, I forgot to show you the wonderful trick that we can scale anything in the Blender, any interface. So we can just press Ctrl and middle mouse button, so we can scale the interface as we want. It doesn't work here, but of course for any kind of this menu. So if you don't see it good or want to scale it, and that's what I really miss in other software. So let's choose the blend mode for transculent. Now I'll go with lighting mode to surface transculency volume. Let's select the color for the bottle, like this. Now let's create some values. So here you can see that this material editor really resembles what we talked about, the physically based material. So ambient occlusion, like many people actually call the ambient occlusion like a crunch, because it's like imitating the shadows without actually calculating the shadows. So here we have roughness, we have the specular color, but actually in physical based rendering the specular is not used. But okay, let's create some constant. We'll use a value of 1. In this kind of material we'll use the metallic. Now let's create some constant. So comparing these constants to the maps, so like roughness map or some other maps, when we talked about the shades or the gray, the black, white, when we represent the numbers. So the black is 0, white is 1. So here, by using the constant of 1 or 0 in Unreal, it just means that we have texture, for example, the complete white texture for the 1 and completely black texture for the 0. So let's change this 0 to 0.5 for now. It will be our roughness. Create constant. Let's take it like 0.7 and put it into the capacity. Let's apply this. So you've applied this thing. So just save this. So we have created this material. Now it will be compiling shaders here. You can see when it finishes, we will see the material. So we'll just save it for now. So fill up these values and save.
Can you show cost of this cost now?
Yes. Just 1 second.
Go.
Blend. It set blend mode to translucent. Sorry. And down. Okay, I'll show you. So we have translucent in the blend mode, and in the lighting mode we have surface translucency volume. Translucency. So here in the preview it looks kind of strange, but let's apply it to our bottle and put it in the scene. So it kind of looks like a glass. So now we can just move it. Let's put it in okay. Oh. So in Unreal we can snap the objects to the bottom by pressing End button and duplicate it. Now, so that's too big, I guess. Scale it down. Let's move it here, something like that. Now, let's apply some physics. And we can play with our bottles. So at this point we can finish our workshop.
Thank you.
So any questions?
Could you
share those files that they created?
Slides? Files?
Slides and files. Yeah.
Okay, I will share them.
And also gets the recording.
Yes, yes.
Of the studio.
Okay, thank you for your attention.